Good morning, I'm Davide Simeone from Webuild, and today I'm going to give you a brief presentation regarding one of our recent research projects, that is the content. It's the development of an ontology to support knowledge reuse in construction tendering. So the scope of this research focuses on the construction tendering phase. It's a very delicate action for a general contractor, and in particular the development of a technical offer to a tender. The aim of this research is to capitalize and reuse knowledge shared and elaborated during the different tenders in order to improve quality and speed of decisions in this kind of actions. The objective specific of this research is to investigate how information ontologies can help a general contractor in formalize knowledge and manage the complexity of this kind of technical decisions. If we focus on the construction tendering phase, we can just say that it's very delicate action that involve multiple and quick decisions by a general contractor. It's a phase where there is a high level of competitiveness because there are different joint ventures usually applying to the same construction tender. It's a very multidisciplinary and collaborative activity because there are different actors involved: designers, construction specialists, the client itself, other consultants. So many people with their own disciplines and skills playing the game of a construction tender. It's a very high risk for a general contractor because the assumption and the knowledge that we elaborate during the tender is something that can affect the result of the tender itself, but also the quality of the process if the tender is awarded. And to conclude, it's a knowledge-driven process. There is a lot of knowledge involved, usually provided by the different specialists involved in the construction tender. So there is this importance, the key relevance of knowledge in this process. As we can say here, there are different sources that provide knowledge during the construction tender. There are the previous projects knowledge. There is the rest of the previous tenders and estimation. So if we made some calculation for some rates, for instance, in a previous tender, we can reuse them we can carefully reuse them in a new tender. There are data that are provided by suppliers, other joint venture members, and so on. There are consultants, specialists, and there is also the tacit knowledge of all the people involved. So everyone has its own knowledge on the discipline that is going to that usually he or she provides during the development of the technical offer. Then there is the knowledge that is already formalized in books, patents, good practices, or norms and regulations on the other side. And to conclude, there is the client and other external parties that can provide their own knowledge to drive you through the process of the construction tender. How this kind of knowledge is today managed by general contractor? What we see usually is a database that is oriented to store some data regarding construction tender and to make them reusable. Relational databases are usually the preferred ones, but there are some limits in their implementation. They have a hidden construction logic. So if you are this kind of databases requires continuous update, also in terms of logic, because the world of construction continuously change. And this can, let's say, that clashes with the rules of control of the construction logic of the database itself. Databases are usually very rigid. They lack on providing the information with the right interpretative context. And there is low semantics. Usually they mainly store numerical values related, for instance, to rates, productions, and so on. And there is the ability of databases to assure data integrity, but not always the data consistency. So we started looking into the linked data work to see if there is a new way to formalize this kind of knowledge. And we discovered that linked data can provide a flexible knowledge structure and the right interpretative context of all the information. Information can be reused and then can provide consistency and integrity of the information that is stored in a linked data platform. So our process of developing the content ontology is actually something that we derived from the meta-ontology framework. It's a bit simplified because we needed to apply it to general contractor processes where not all the people are researchers, but they have their own experience and knowledge regarding specific disciplines. So we analyze the requirements and the portfolio of the contractor. Then we define some major areas where we needed to develop some, let's say, subdomain ontologies. And then we develop the ontologies by looking in for existing ontology in the same field, because this is a very horizontal ontology, and there is the risk of going too much in detail in too many fields, making the ontology not really helpful to the general contractor. And then we applied the model, the ontology. We are calibrating, refining the ontology by applying it to previous projects and ongoing projects. So we define three major areas. The first one is the framework knowledge. It's the one that helps the management of the portfolio. So it gives you all the information regarding how to locate the project, the business market, the kind of procurement route, and so on. Then we have the definition knowledge. So all the knowledge that describe the project in terms of, for instance, parts, components, requirements, issues, and so on. And then there is the reference knowledge, this body of knowledge that we are developing that is actually external to the project, but it provides, it influences, and it, in some case, motivates some of the decisions made during the construction tendering. This is just an example of the project framework knowledge to see how the things start to be very complex very easily. And in this case, we just we developed a simplified ontology that its aim is not to cover everything, but to cover just the things that are essential for a general contractor. This is an example of one of our implementation where the content platform is able to motivate the selection of a specific TBM, tunnel boring machine. You can see here the sluggish shell TBM on the right, based on the set of information regarding the geography, the kind of soil that we are going to expect, and the data regarding different machines that we have stored in the platform, and so on. This is just an example that shows you the potentialities in describing the decisions that are made during the construction tender. Obviously, we are looking into several reference ontologies because we don't want to reinvent the wheel, and there is so much that is already available. So these are just some of the ontologies that we are looking into. The building product ontology is very general and helped us in developing the flexible general ontology. IFC OWL, we use this kind of ontology, but less than in other projects, because we are still working at a higher level in terms of description of the project, right? The IFC OWL is very, very good for expressing components, for instance, in the project itself. Then there are some others. I will just now, without talking too much on them, there are very specific ones as the Deacon ontology, very recent, but there are also the very general ones as the friend of a friend or e-procurement and so on. What we can say in this process is that we saw some key points emerging. The first one is that the knowledge base is going to be very wide. So where and how we should prune this knowledge base. Another key aspect is that is related to the if and how the ontology provided, developed by the general contractor should be public or private, because there is the general contractor perspective on this kind of database, of knowledge base, sorry. And this can be very risky, probably, for a general contractor. And there are some other points I will just point out, for instance, that we really need of the involvement of all the different specialists in developing and assessing the ontology itself. And probably there is a new profile, a new kind of operators that are needed into the construction tendering process. To conclude, let's say that linked data and semantic web technologies show great potentialities in knowledge reuse, especially in the ability of capitalize knowledge rather than data. There is this problem of balancing the linked data, let's say, democratic philosophy and the preciousness of the general contractor data and information. And for future developments, we are at the moment we are still in the process of developing this ontology. But in our idea, we should focus also on how to automatically collect this knowledge through the process and to make it reusable, for instance, through a design support system. So thank you for your attention. Please feel free to ask any question.